Thanks for joining today. My name is Mike Bruce. As Sue mentioned, I am the DevOps principal at Improving, and for the last few years, I've been focused primarily, almost 100%, I'd say, on DevOps. I'm going to kind of cover some stuff out of the Phoenix Project book called The 3 Ways. But before I do, just a couple hypothetical questions for you. One is, what would it mean to your company or to your team if you could cycle faster and have less errors and issues? The 3 ways, we're going to talk a little bit about how we can make that idea a reality and what it's going to take to do that. So before we used to have to deal with deployments in a way that seemed kind of convoluted, right? So the development team would spend a few months developing software, and then QA would get that software and test it. And if there was a bug, send it back to the development team. And then they'd have to do context switching, which means stop doing what they're doing and go back and fix those bugs. And that caused a lot of issues from being able to deploy. What we're going to talk a little bit about today is how do we cycle those deployments a lot faster and a lot safer. And it's going to be on the 3 ways. So let's get started. The first way, the principles of flow. Okay, so the first way is really about the principles of flow. And there are really about 4 main things about the principles of flow. So we have really like the left to right movement. We have the smaller batch sizes with things. We try to also focus on any constraints, and we'll talk a little bit about what the theory of constraints is. And then also no downstream defects. Each one of these portions for the first way is really all about how do we flow from development and idea all the way through to a finished release product. And so what we're going to do is we'll just talk a little bit about the whole entire left to right flow. Now, if you've been in QA for a long time, you know that you used to get stuff thrown over the wall and there it is, go QA everything. But what we try to do now with Agile and Scrum processes is to take those things that we would just throw off to the end. We try to do those a little earlier in the process, a term called shift left, you may have heard of it, and start to figure out what can we do in small little areas on the left-hand side where the development team would do stuff, so it'd be unit tests, and then migrate or move that piece of work from the left side to the right side on a Kanban. So as you see in that picture, we really have the to-do, doing, done type situation on a Kanban board. Now, this isn't anything new if you've been doing software, right? We want to get that stuff over, but moving stuff left to right is really to have a good flow of work moving from the left side of that Kanban to the right side of that Kanban. This also follows along the manufacturing TQM principles from Toyota and their quality management. TQM, Total Quality Management, was the Toyota Quality Management, I forgot which one. But that is really the process of these smaller batches. And these smaller batches, as we start looking at that, is really going to be about not this traditional waterfall, which is what you see here, but really is how do we get smaller batch sizes that we can test and deliver faster. And there's really a pretty fine art to doing this, right? It's not hard, but you do have to work at it. But before I talk a lot about it, I would like to show you something that's really kind of interesting that I had my kids do. So bear with me for a couple of minutes as I show you this video of my kids in playing a game of dice. Hi guys. Hey, thanks for helping me out here. I really appreciate it. Each of you have a job to do. Okay, you guys good for that? All right, so this could be really, really easy. We're gonna just take a bunch of dice and we're gonna slide them on over to Nicholas. There you go, Nicholas. Now don't start yet. what you're going to do is you're going to find the lowest number on every single one of those dice. And once you find it on all of the dice, you're going to pass them off to your sister who's sitting right next to you. And then, Sophia, when you get the dice, you're going to do the same thing to the next lowest number. When you get them all done, you're going to pass them to your brother and Alex. When you're all done, you're going to find the next number and you're going to put them all to the center. But here's the thing. We have done 2 minutes time.
That is so hard. That is so hard.
That's right. It is going to be hard. Are you ready to get going? So let me see these dice. Let me see these dice, Nicholas. Are we ready? Okay, Sophia. You don't snatch the dice. No taking the dice. On your mark, get set, go. So we got the number 1. We got 1 on it. We'll just do 1 in here. We can see that we're getting all these 1s for all the dice. We ran out of time. So why don't we try now with using the principles of flow. All the dice with the third highest number that is on the dice, and this represents the delivery value, and we haven't even finished the time. So as you can see, when we have to deliver a lot all at once, we may not get the full benefit of everybody that happens to be in that chain or in that cycle or each section of our Kanban. When we break that down into smaller chunks of manageable things, we also reduce the amount of wait time that the next person in the chain has to deal with. And as you can see from that video, if we only had that 2 minutes or 2 months, let's say, the amount of value that was delivered at the end of that was nothing. But when we decided to break that down into smaller, more manageable chunks, we actually improved our flow and were able to deliver 100% of our value that we were trying to deliver. But that's not the only thing that we have to focus on when we talk about the principles of flow. We do also have to talk a little bit about some of the constraints that we have in this. So really what we have here is when we have a problem in something, so let's say that not everything is going well, we want to address that not going so well as soon as we can in this process. And we'll talk a little bit more about that in the second way when we get there. But one of the most important principles that you'll take away from the principles of flow is smaller cycles, not passing the defects downstream, and then also moving from the left to the right on your Kanban. Now that Kanban can be digital, as in Azure DevOps or in Jira, or it can be a physical board, a whiteboard that you may have in your office. So, and there are also other free Kanban tools that you can download on the internet or actually run online. So those are really exciting tools that are out there for you and for your teams. Now, if you are still delivering big chunks of code, then the question remains, how can we get the value faster to our customer? And that customer could be internally or externally. And that's really kind of what we want to focus on, is that continuous flow. So let's go ahead and move on to the second way. The second way, the principles of feedback. So we learned a little on the first way about how we can move from left to right. But really the second way is really kind of like, well, what do we do? How do we do that? And so what we're going to do is we're going to talk a little bit about the principles of feedback and what that means. So in a nutshell, there are really three main things on the feedback is how do we prevent those problems so we can have feedback, we get feedback on that. How do we recover faster when we have an issue? And then of course, pulling the virtual and-on cord. Now, if you're not familiar with an and-on cord, I'll show you in a second what that is. But basically what we're gonna do is we're gonna talk a little bit about preventing problems and why is that important. So let's take a look at something that's really kind of a big deal. So you may have seen this, or maybe not, but this right here is something that happened a few years ago. And what this is that this company, Knight Capital Group, happened to deploy their software on 7 or 8 servers, and one of those servers did not get updated correctly. What ended up happening when they deployed is the trading algorithms for 7 of the 8 servers was set correctly, but the 8th one was not. And what ended up happening is that the servers started pretty much, in an easy way to say it, betting against each other. And they ended up losing $440 million in a span of 45 minutes. Now, if that's not a cautionary tale of why we want to catch this stuff earlier, I'm not sure what is. However, what about something that happens like this when we start talking about massive amounts of credit information and user data getting stolen or taken from Equifax? So probably everybody that's on this call, myself included, has their social security number hacked from Equifax back in early 2019. This is obviously not good. So what we want to do is we want to be able to capture stuff a little bit earlier than at the end of the cycle. And we do that in order to find these bugs and everything earlier. So this feedback loop. Some of the things we can do for a feedback loop is doing this technique called shift left. And shift left is really kind of a simple way to say, test earlier, test often, and test with smaller bits of code. So instead of trying to, test an entire application once it's fully developed, what about testing it on the first version of the UI? So we can start seeing as testers, well, what's coming? What's it gonna look like? Can I start clicking through and understanding the flow of the app, and how does it differ, or how is it the same from our mock-ups that we may have gotten from the business? So that would be one way to get feedback early, is to actually just go look and start testing what you can as early as you can, any user stories that may have been completed for a sprint. That also requires on that feedback being able to deploy software a little faster. And so that happens to be the part of the principles of flow, so we can code, test, deploy. And part of that feedback is once we deploy, have we deployed it properly? And then have we started our testing immediately on what's deployed? And deploy does not mean production. Deployment really means deployed to somewhere where I can actually start testing it. So hopefully you've dealt with a dev environment, a QA environment, and maybe even an automation, a staging, as well as, of course, your production environment. When we talk about feedback, feedback to the developers may be that the software deployed properly. It may be that the unit tests all passed. It is also when the developer gets a defect logged in the system. And so what's really important to understand is that feedback has to be fast, has to be relevant, it has to be, of course, timely for that to be of any usefulness. But feedback doesn't stop with just the software when you're testing it. Feedback also stops when we happen to want to look at the end of it, when we deploy that feedback, and that feedback from the business or from our end users. And there are several ways that we can deal with feedback. Of course, we can deal with feedback by The happy or not button. So that's feedback. You know, is it relevant? It might be. Take for instance, if you and I both walked into Walmart and saw this, and I just checked out, and I was really happy with everything, and I hit the happy button, and maybe when you went, you were not very happy because you couldn't find what you wanted, right? So checking out was fine. The cashier was nice. You did get some things that you needed, but you couldn't find that special lettuce you wanted for your salad. And so you weren't happy, you hit a 1. Now, the 5 that I pushed, the 1 that you pushed, is going to be aggregated somewhere, but all it says is that, you know, people are okay. You know, there's a 3 average with the store, but it's not relevant to anything that they can address or fix. So the feedback, while it's there, it's just not, it's really not helpful in a way, right? So, hey, look, we got a bunch of 5s, great. Or, hey, we got a bunch of 1s. Well, what do you do with those 1s? What are you supposed to fix? Was the food cold? Was the lettuce not green? Was the cashier mean? Or was the software just not working, right? So the happy or not, you know, great, you got some feedback, but it's not really relevant. And is it timely? I don't know. You know, what if I spent 2 hours looking and then I wasn't happy and I hit a 1, but I just checked out, I was happy, I hit a 5. So timeliness, of course, matters. But if you take something like an app that you download and you want, and you know, we're getting solicited all the time for feedback, right? We're asked, rate this app. So if I'm in the middle of the app and something happens and I'm not really happy about it, and that thing pops up, says rate this app, and I say 1 star, it does give me the opportunity to explain why I gave it a 1 star. So that feedback is timely, and it also is relevant because I'm able to tell it what I want to do. So our feedback has to be relevant and timely, and it has to be more immediate than you know, waiting forever for an entire application to be deployed 5 months later. So that's that first part. But also feedback can take the form of a lot of things, and we're going to get to the andon cord. So Toyota has this system called an andon cord. Now, it's not an andon cord anymore. They've changed it. Technology advanced. But basically, it was a cord that over every person on the assembly line had a cord above them called an andon cord. And this andon cord could be pulled by anybody on the assembly line at any time. So that feedback right there goes to the senior person on the line, and if need be, someone higher than that person. So you have an issue. Let's say a part's not fitting properly now on your car. You have this issue, you pull the andon cord, and the team lead or the leader of the assembly line comes over and starts to address that problem right then, right there, immediately. And if possible, tries to solve the issue so everything downstream, every car that is going to be manufactured won't have that problem going on. So why is this important? Well, let's take a look at why this is important. And if you've never seen this movie, I strongly urge you to watch the movie. This is funny stuff.
I'm gonna have one of these cars we made together by hand. Your guys and my guys together. You know why? Those cars stand for something. Those cars stand for something pretty great. I'm proud of those cars. I'm taking them. Gentlemen, I'm going home in my new car. tell you, I thought it handled great.
Hey, for that 5 feet that he drove, it probably did handle great. And that's sometimes how developers and well, I guess it's not fair to say, but that's sometimes how developers may feel if it works on my machine. And so if we don't have that feedback earlier, then it runs great. I don't see what the problem is, and we don't test it early and often and provide that feedback. Then we can't say that it's gonna run any better past that 5 feet. That 5 feet being, of course, the next environment in our flow. So the and-on chord can be virtual in our case. And so in the Scrum process, if there's a problem, we have what's called a blocker. And that blocker is used to say, we have a major problem with something and we need to address it now as a whole, and we need to Scrum on top of it. So if there's a problem with deployment, then we need to find out why is there a problem with deployment? Is there a problem with any of the automation? Is there a problem with the server it's being deployed to? How about a problem with the code, new code that just got made? It made it to the QA environment, but there's something wrong with the production environment that's not allowing it to deploy. If there's a problem that the testers come across, it's a fringe case. How do we get that information and feed it back to the development team in a timely, relevant manner so they can code for that exception or that fringe case? So feedback is extremely important in the 3 ways. So we did talk about the first way, and that was the principles of flow. That is, how do we get software from point A to point B to point C to the end of the line? We talked a little bit about the principles of feedback and why that is important. Let's talk now about the third way. The third way. The principles of continual learning and experimentation. So the third way is all about the ability to take a little bit of risk, to experiment, and to learn. So if we deploy software and that software happens to have a defect, then hopefully when that defect goes back to the development team and we see, oh, you know what, I should have used a do while loop instead of a while loop because it has to execute at least one time. Maybe that right there is a good learning opportunity from that feedback. At the same time, let's say as a developer, I want to start learning a little bit more about parallel programming. And instead of a regular for loop, I want the opportunity maybe to experiment on using the parallel for. And so those kind of things are ways to experiment. Another way to experiment is to find new ways to automate some of our testing. And I have a fondness for this story I'm about to share with you. One is because Costa actually used to, he developed and invented this really cool system for testing apps on a mobile phone. And a company that I worked for, we had to test physical phones against light fixtures. And these light fixtures were in the ceiling. And so we had a couple of challenges. One is, how do we update the software inside the light fixture because they had software running? And then how do we get the software to our phones faster? So when we first started this out, we had one test engineer. And that test engineer had to download the application to his Mac. He had to compile it, side load it onto his iPhone. And he had one light fixture that was there. So he had to interact with that light fixture. Now, the challenge that he ran into was the fact that if something happened where he bricked the light fixture, he had to go find another light fixture with the software installed, or call the engineering team that wrote special code that could unbrick this light fixture. Now, mind you, in this case, the light fixture was sitting beside him, not up in the ceiling. At the end of the day, when we started really looking at how can we automate this, we took a lot of risk and we took some time to experiment. One is, how can we not have to have the engineer come and fix this light fixture? So we asked one of the engineers to write us a script that we could run and pushed to the device. Now the question was, how can we push that software to the device expeditiously? And we found that we can wire these light fixtures up with Cat5 cable and USB. So we were able to push data to these light fixtures anytime we wanted to flash them, even if they were bricked. Then what we had to do is take the device and all the inventions from Costa and incorporate that into our build and release process, in which we took software from our Git repository, compiled it, and instead of pushing it out to Apple or to Google Play stores, we would push it down onto an Appium server. And that Appium server would actually run some unit tests for us, pushing it straight down to a mobile device, which was configured to connect to those light fixtures. And now at the end of it, through experimentation, we were testing thousands of lights per minute versus one light per hour. So we had that flexibility, and we got that flexibility because of a couple of things. One, we wanted to be innovative in how we delivered stuff. And innovation is really kind of critical on the third way. If you don't figure out new ways to do something, you're not advancing the process. All you're doing is click, click, click. Okay, I'm done. Click, click, click. Okay, I'm done. And that is not any fun to be on the side of it. So we wanted to innovate, and we were allowed to innovate. And we had to take risks. We didn't know if the way to do this with the Appium server and the mobile devices was going to work. But what we were allowed to do was to learn where things failed and fix it. But most importantly, we had a lot of trust from our organization to test that out. So the third way is really all about learning and experimenting. And so here's a couple of things as to why that's important. The product you see, WD-40, I bet everybody has a candidate or has used WD-40. It's called WD-40 for a really good reason. Excuse me, and that is because it took 40 tries to get the formula for water repellent to actually become useful and marketable. Now, I'm sure WD-39 would have been okay, would have probably been good enough, but maybe something was off where it didn't work too well. Also, quite frankly, I think the name would suck, WD-39. Maybe we're just so used to WD-40. WD-1, that was obviously not going to work, but there was something that was learned from it. There was risk that taking on adding a different chemical ingredient, as well as maybe a little experimentation, some feedback on if it worked or not. So that was really important. But really also, here's kind of some more interesting stuff, right? Is to experiment, we also need to find out what's going wrong with it. And to do that, there are a lot of tools that DevOps, QA, IT operations, and anybody that's like a reliability engineer can put into play on their infrastructure. And that is really called chaos management. So this kind of term, I'm not sure if it was originated by Netflix or not, but Netflix provides a lot of tools that are free for us to download off of GitHub that can help us to go through and simulate problems that we can then try to fix. So for instance, they have a way to cause a network outage on one of their networks, and they can go through and try to troubleshoot. A company called PagerDuty does the same thing, where they have these Fridays where they will stage an outage, and they will cause everybody to get into a conference call and to build a solution for something that has failed. And that could be maybe a server goes down, maybe there's a network node, maybe there's bad code, but they will deliberately inject an issue and then have their teams get on and try to troubleshoot and fix that issue as fast as possible. So those kind of things are a way to help with experimenting, learning, and really just stepping up on that third way of the principles of experimentation and learning. But really what's also very important here is we have to be careful of the status quo. So I am sure we have all heard, that's just how we do it here. That's what we do. And there's a problem fundamentally with that belief. If that's how we always do it, then why are we writing new software? We already have software. That's how it works. So let's stick with it. If you continue on the status quo path, you will not learn from your mistakes. You're just going to repeat those mistakes. You're not going to feel like you can experiment and maybe try something like Cypress, or maybe you want to get into Selenium or you're afraid to code. Those are the things like getting in there and experimenting and trying and learning are what's going to accelerate the ability to deliver software fast. So it's really kind of important. And so what we want to actually take a look at is think about how we can focus our time. And there's a lot of things around that. And so I'm going to wrap it up really soon here, is that you have a lot of like options, right? A lot of tools to color the picture you want to. And you can do it using markers or paints, crayons. But the idea is to focus on how do I experiment and learn at the same time as being able to deliver fast. And a lot of people have told me, well, it's not doable. You know, we're going too fast. Well, my question back is, well, what can you do better and maybe in smaller increments? And how can you do that in such a way that allows you to not get in that status quo method? So in summary, right, there are three ways, right? And you can see that it's the principles of flow, which is all about continuous delivery of value, right? If you can deliver everything and it's never ever deployed, well, it's why deliver it? Why produce it? And so that CI/CD process that everybody hears about, that is the continuous principles of flow. The principles of feedback is always about testing. Whether that testing is done by the developers with unit tests, or at the end with an end-to-end systems integration test, or all the testing that happens in between, the principles of feedback come into play on how do I get what I'm doing now, and how do I get that a little bit earlier, and be able to share with the team what's happening in a way that they can fix it without having to task switch. Task switching is dangerous. If you switch tasks, say twice, or you switch tasks once, you lose about 20% productivity. If you have two tasks you're trying to switch between. You do that 2 times, you've just lost 20% of your productivity. So instead of running at 100% of productivity on what you're doing, you're now running at about 80% trying to handle 3 tasks. And you cannot address that. And so a part of the principles of feedback and the principles of flow is all about addressing what's called the your bottleneck. And it's really about the bottlenecking and how much can you take on as a person. So if you haven't read it, read the Phoenix Project. It explains it much better than I in 25 or 30 minutes. And the third way is really about the principles of learning and experimentation. And that happens to be all about continuous growth. That's really about the 3 ways. I hope in the 45 minutes you gained a little bit of knowledge on it, but I am absolutely welcoming any questions you may have. And go ahead, fire away. Looks like the question, and if I get it right or wrong, if I get this wrong, please go ahead and just say so in the chat. But the question is how does this affect requirements development and user story development? That's a very fair question, right? So typically, you know, I've heard this a lot on, hey, we have a lot of user stories, and if I write a user story, does that mean development team's going to go write the code for it? And really, you know, a user story is to say, hey, I want to do this piece of functionality on my app. Generally speaking, though, you already have an idea of what that app is, and there is obviously some documentation that is written before anybody ever writes a piece of code, and that is, hey, I want to go build an e-commerce app that sells potato chips. And now everybody knows I'm going to build an e-commerce app that builds potato chips. But if I just wrote a user story or a requirement that says user clicks on a button to buy potato chips, I have absolutely no idea what the context of that user story is. So a user story just by itself is really useless. It has to have that context about what is a part of the system. What are we building? So when it comes to project management, we obviously will have a starting point, right? We don't get a bunch of people in the room and say, go code. We may say, hey, we have this idea. We get everybody involved if it's a small team. We have an idea of building an e-commerce site around potato chips. So there may be somebody that is good with UI, says, hey, I can mock that up for you. And let me do some mock-ups. Now that mock-upping of a website or an app could definitely be a user story that says, create mock-ups for an app. And obviously that doesn't go through like a formal testing, but there is a review so that could become a user story. The framework for the software, like, are we going to write this in Xamarin? Are we going to write this in iOS native Objective-C? Or are we going to write this in Java and Android apps? Those kind of things are starting to get defined. And those can be user stories to help define the project as a whole. But then when it comes down to those features, when I get a new feature requirement, I know that I'm not starting from nothing, not having any idea what I'm doing, right? I am going to be starting with, hey, we're going to build this potato chip app. And we're going to add those user stories as fast as possible and then start flushing those out during sprint planning. It's sprint planning that you're going to start seeing, hey, we need to add some acceptance criteria. And if you ever deal with a team that's sending you user stories without acceptance criteria, push it back, because to me, that's allowing a defect downstream. That defect being it doesn't have acceptance criteria. If it doesn't have acceptance criteria, how do I know what I'm testing? So when we start developing all of our user stories, we have an idea of the application that we're going to build and the system we're going to build. We may not have everything roughed out, but we have an idea, right? We may have a couple of people generating mock-ups. We may have a couple of people that are putting together the main elements for our application, the architecture for it. And then from going forward, as we're adding more, those user stories are put into the backlog and added during sprint planning, basically doing standard Scrum processes. I hope that answered your question, Richard. Let's see. So the question is, will this process work for a team with no quality engineers? And if there is a separate quality team that takes care of overall quality of product rather than the sprint work is performed by the dev team, including testing, what changes have to be made to the process to adapt? So that's fair, right? So I've been in organizations that have a separate QA team, and that's okay, right? But the problem is if that QA team is getting an end result, the feedback becomes less relevant for the development team, and they have to switch context. So they're focused on feature B, and you found a bug in feature A, and so now you've got to go and say, hey, there's a bug in feature A, and they're like, oh, let me stop, let me fix feature A, and then redeploy it. And then they have to swap their thought process back to feature B. So how do you make these changes to make the process better? One is, I guess the first thing is just see if it's possible to have a QA engineer assigned to that dev team. If not, make sure you have full visibility into the dev team's work and that you're getting their work as soon as possible. Make sure you have access to their Kanban boards, to their user stories, and to the developers as you need, not as and going through a third party like a PM or something. Okay, let's see, Richard, do you see requirements lists as well as user stories in some projects? Yeah, sure. I mean, user stories are your requirements list, right? So, what's kind of interesting, like I am an expert in Azure DevOps, and you can export all of your user stories, just the titles and how many story points they are, into Excel. And then you have a list, and you can take that list and you can share around the organization. Say, hey, here's all my requirements. They don't have to be even user stories. They could be features or epics, right? So there are different hierarchies in Scrum that you could say, here's my feature list. And also you can create a query. So in both Jira and Azure DevOps and TFS and probably a couple others, is you can query for items for this sprint. And what you output during that sprint is just a list of items. Those are your requirements. I do appreciate your time, and thanks for joining us on the AQAA. Working with Costa has been a lot of fun. Appreciate all that you're doing. All right, I'm going to sign off. You guys all enjoy the rest of the conference, and I hope you all have a good day. Thank you very much for having me.
Thank you so much, Mike.
You're welcome.